Welcome to the brand new section of this course, Strings, Stream Classes and Regular Expressions. Now let's move on to the video, Creating, Concatenating and Transforming Strings. Let's take a look at the entire code example. We will create strings and string views and do basic concatenation and transformation with them in this video. As always, we first include header files and declare that we use the standard namespace. In the main function, first create string objects. The most obvious way is instantiating an object A of class string. We control its content by giving the constructor a C-style string. The constructor will copy it and make it the content of string object A. Alternatively, instead of initializing it from a C-style string, we can use the string literal operator. It creates a string object on the fly. Using that to construct object B, we can even use automatic type deduction. The strings we just created are copying their input from the constructor argument into their own buffer. In order to not copy but reference the underlying string, we can use string view instances. This class does also have a literal operator, and it is called double quotes SV. Okay, now let's play with our strings and string views. For both types, there are OStreams operator overloads for the OStream class, so they can be printed comfortably. As you can see, we have printed both string and string views. The string class overloads operator addition, so we can add two strings and get their concatenation as a result. This way, A plus B results in AB. Concatenating A and B this way is easy. With A and C, it is not that easy because C is not a string but a string view. So we have to get the string out of C first, and this can be done by constructing a new string from C and then adding it to A. As you can see here, first we have constructed the new string from C and then added it to A. At this point one could ask, wait, why are you copying C into an intermediate string object just in order to add it to A? Can't you avoid that copy by using c.data? That is a nice idea, but it has a flaw. String view instances do not have to carry zero-terminated strings, and this is a problem that can lead to buffer overflows. Now let's create a new string, which contains all of the strings and string views we just created. As seen, we have created OString stream O. By using OString stream, we can print any variable into a stream object that behaves exactly like cout, but it doesn't print to the shell. Instead, it prints into a string buffer. After we streamed all the variables with some separating space between them using OStream operator, we can construct and print a new string object from that with O.string. We can now also transform that new string by converting all its letters to uppercase, for example. The C library function to upper, which maps lowercase characters to uppercase characters and leaves other characters unchanged, is already available and can be combined with transform because a string is basically also an iterable container object with char items. So after the in-depth explanations, it's time to compile and execute our code. Go to your terminal, type in the command for compiling the code. After the successful compilation, let's execute it. Great, we obtained the output as expected. First, we get string and string view. We get the values AB and AC. In the last two lines, we obtain the lowercase characters and uppercase characters. Next, we will be trimming whitespace from the beginning and end of strings. Let's take a look at the entire code example. So go to the Atom editor, then click on the ex2 directory, and inside that, click on the trim whitespace.cpp file. This is the entire code. Here, we will define a helper function that identifies surrounding whitespace in a string and returns a copy without that, and then we are going to test it briefly. So let's understand this code in detail. As always, the header includes and using directive come first. Next, we have implemented our function to trim whitespace surrounding a string, which takes a const reference to an existing string. It will return a new string without any surrounding whitespace. The string provides two handy functions, which helps us a lot. The first is string find first not of, which accepts a string containing all the characters we want to skip over. This is, of course, whitespace, meaning the character space tab a new line. It returns us the first non-white space character position. If there is only white space in the string, it returns string npos. This means that there is only an empty string left if we trim white space from it. So in such a case, let's just return an empty string. We know now where the new string has to begin, but we don't yet know where it has to end. Therefore, we use the other handy string function, string find last not of. It will return us the last character position in the string which has no white space. Using string substring, we can now return the part of the string which is surrounded by white space but without the white space. This function takes two parameters, a position in the string to begin with and the number of characters after this position. That's it. Let's define a main function in which we create a string that surrounds a text sentence with all kinds of white space in order to trim it. Next, we print the untrimmed and trimmed versions of the string. By surrounding the string with brackets, it's more obvious which white space belonged to it prior to trimming. Now let's compile and execute the code and check what output it yields. Go to the terminal, navigate to the directory ex2. Next, we will clear the screen using the reset command. After that, type in the command for compiling the code. After the successful compilation, let's execute it. Excellent! Here is the required output. We got the output as expected. First, we get the untrimmed version of string, and then get the trimmed version of string. After that, we will be getting the comfort of string without the cost of constructing string objects. Let's take a look at the entire code example. So go to the Atom editor, then open the ex3 directory, and inside that, open the respective .cpp file. This is the entire code. Here we are going to implement a function that relies on some string view features, and then we see how many different types we can feed into it. So let's understand this code in detail. The header includes and using directive come first. We implement a function that accepts a string view as its only argument. Before doing anything with the input string, we remove any leading and trailing white space. We are not going to change the string, but the view on the string by narrowing it down to the actual non-white space part of the string. The find first not of function will find the first character in the string, which is not space, not a tab character, and not a new line character. With remove prefix, we advance the internal string view pointer to the first non-white space character. In case the string contains only white space, the find first not of function returns the value npos, which is size type -1. As size type is an unsigned variable, this boils down to a very large number. So we take the smaller one of both, words begin, or the string view size. Here we have used words begin. We do the same with trailing white space. The remove suffix shrinks down the view size variable. Next we can print the string view and its length. In our main function, we play around with the new print function by feeding it with completely different argument types. First, we give it a runtime char string from the argv pointer. At runtime, it contains the file name of our executable. Then we give it an empty string view instance. We then feed it with a C-style static character string. And in our fourth function, we provide it with a double quote SV literal, which constructs us a string view on the fly. And finally, we give it a string. The nice thing is that none of these arguments are modified or copied in order to call the print function. No heap allocations happen. For many and or large strings, this is very efficient. We did not test the white space removal feature, so let's give it a string that has a lot of leading and trailing white space. Another cool feature is that the string view gives us access to not have to be zero terminated. If we construct a string such as ABC without a trailing zero, the print function can still safely handle it because string view also carries the size of the string it points to. So it's time to compile and execute our code. Go to your terminal, navigate to the directory ex3. Next, we will clear the screen using the reset command. After that, type in the command for compiling the code. After the successful compilation, let's execute it. Nice! We obtained this output. All the strings are correctly handled. The string we filled with lots of leading and trailing whitespace is correctly filtered, and the ABC string without zero termination is also correctly printed without any buffer overflows. Finally, we will be reading values from user input. Let's take a look at the entire code example. So go to the Atom editor, then open the ex4 directory. And inside that, open the respective .cpp file. This is the entire code. Here, we are going to read user input into different variables and see how to handle errors, as well as how to do a little bit more complex tokenizing of input into useful chunks. Let's understand the code now. We only need IOStream this time, so let's include this single header and declare that we use the standard namespace by default. Let's first prompt the user to enter two numbers. We will pass them into an int and a double variable. Passing and error checking is done at the same time in the condition part of our if branch. Only if both the numbers could be passed are they meaningful to us and we print them. If the passing did not succeed for any reason, that is, if condition did not work, we tell the user that the passing did not go well. The cInStream object is now in a fail state and will not give us another input until we clear the fail state again. In order to be able to pass a new input afterward, we call clear function on cin.clear and drop all input we received until now. The dropping is done by ignore function in cin, where we specify that we are dropping the maximum number of characters until we finally see a new line character, which is also dropped. Everything after that is interesting input again. Let's now ask for some other input. We let the user enter names. As names can consist of multiple words separated by spaces, the space character is not a good separator any longer. Therefore, we use the getLine function, which accepts a stream object such as cin, a string reference where it will copy the input into and a separating character. Let's choose comma as the separating character. By not just using cin alone and by using cin on ws as a stream parameter for getLine instead, we can make cin drop any leading whitespace before any name. In every loop step, we print the current name, but if a name is empty, we drop out of the loop. Now let's compile and run the program. Go to your terminal, navigate to the directory ex4. Next, we will clear the screen using the reset command. After that, type in the command for compiling the code. After the successful compilation, let's execute it. First, it will ask us to enter two numbers, in which we assumingly entered only valid inputs. We enter 1 and 2. The numbers are 1, 2, which are passed correctly, and then we enter some names like John Doe, Ellen Ripley, then Alice, Chuck Norris, then type in commas twice, which are then also listed correctly. An empty name input in the form of 2 consecutive commas quits the loop. Let's run our program again. So type in the ./a.out command. We will enter the bad numbers, non-numeric, in the beginning. After entering bad numbers, non-numeric in the beginning, we see that the program correctly takes the other branch, drops the bad input, like, oh no, that did not go well, and correctly continues with the name listening, like, now please enter some comma-separated names. Now we can play around with the cin.clear and cin.ignore lines to see how that tampers with the name reading code. So enter some comma-separated names, Bud Spencer, Terence Hill, double commas, and hit enter. Cool! We get the names Bud Spencer and Terence Hill. So here we have come to the end of this video. In the next video, we will do some operations with file.